Think about the last time you deposited a check. Did you actually go to a bank, stand in line, or did you just pull out your phone, snap a couple of pictures, and you were done? That jump from a physical chore to just a couple of taps on a screen is honestly incredible, and it's all powered by this hidden world of technology. So let's pull back the curtain and see what's really going on behind that simple camera flash. So here's our game plan. First, we're going to talk about the problem with paper. Then we'll get into the solution that's probably in your pocket right now. After that, we'll dissect what a digital deposit is actually made of, meet the digital fraud detective that keeps your money safe, and wrap up with how every single phone has basically become a tiny bank branch. All right, first up, the problem with paper. To really get why today's tech is so amazing, we've got to take a quick look back at how things used to be. And trust me, it wasn't that long ago that everything in banking revolved around paper. I mean, just look at this contrast. The old way, then, that meant your whole day was structured around bank hours. You had to physically go somewhere, wait in line. It was slow, it was inefficient, but now it's instant. It's on your schedule, from your couch, from anywhere. This one comparison really says it all, doesn't it? It's a massive shift. So what made this huge leap possible? What was the actual invention here? Well, that brings us right to our next section, the solution in your pocket. This is where a game-changing piece of tech took banking out of the building and put it right into the palm of your hand. The magic behind it all is a technology called Remote Deposit Capture, or RDC for short. And the concept is, well, it's simple, but it's totally profound. It means that a high-quality digital image of a check legally takes the place of the physical paper. Let me say that again. The image becomes the transaction. It's not just a picture anymore. It is the official thing being exchanged. Okay, so let's get into the nitty-gritty. What is actually happening in those few seconds after you hit the submit button on your banking app? Because I promise you, it's a whole lot more than just emailing a photo. So it's like this super fast digital assembly line. It all starts when you capture the image, right? Instantly, software starts pulling out all the key data, account numbers, the dollar amount, everything. Then that info gets validated and logged. And finally, the whole digital package is shot over to the financial clearing system. That's the huge network banks use to move money between each other. It's the same journey the paper check used to take, but now it happens in seconds. And that digital package, it's not just the front and back photos. Oh no. It's this incredibly rich collection of data. It grabs the microdata, that's that funny-looking line of numbers at the bottom of the check, and it checks it against the amount you typed in. But it also logs the exact time, your approximate location, and even data about your specific phone. All of this information creates a unique digital fingerprint for that one transaction, and that is absolutely crucial for the next step. Because naturally, with all this convenience, you open up a huge potential for fraud. I mean, how do banks stop the whole system from collapsing when millions of these digital deposits are flying around every single day? Well, that brings us to the unsung hero of this entire process, the digital fraud detective. And it's a really important question, right? If an image is now as good as cash, what stops somebody from depositing the same check at 3 different banks or photoshopping an extra zero onto the check amount? The answer is a massive, interconnected web of data. In just milliseconds, powerful risk engines analyze that whole data package we just talked about. And really, this is where the history of database technology becomes the star of the show. The ability for different banks to query these gigantic shared databases almost instantly is what makes the whole thing work. It's a feat of data processing that would have been complete science fiction just a couple of decades ago. So, what are these super fast systems actually looking for? Well, they're running a bunch of critical checks all at once. First, they scan a massive shared database to see if that exact check has ever been deposited anywhere before. That's the duplicate check. Then, image analysis software scans for any signs of digital tampering. Next, it runs a simple logic check. Does the amount you typed in match what the computer reads on the check? And finally, it looks for weird behavior, like a brand new account suddenly trying to deposit a bunch of really large checks. Now, this technology feels so normal now, but it didn't just appear out of thin air. Its journey really shows how a powerful idea can start small and evolve into something that, well, puts a bank branch in literally every single pocket. If you look at the history, RDC didn't even start on phones. It was born back in the early 2000s for big businesses that had these huge, expensive desktop scanners. The real revolution, the moment it changed for all of us, was in the 2010s with the smartphone boom. Suddenly,
Everyone had a high-quality camera, a powerful little computer, and an internet connection in their pocket. That's what brought this corporate-level tech to the masses. And now, it's not even a cool feature anymore. It's just banking. It's completely standard.
So the next time you snap a picture of a check to deposit it, just take a second to remember what's happening. You're not just taking a photo. You are creating a complex, secure, information-rich data package that's being checked for fraud and routed through a global financial system, all in a matter of seconds. It really makes you wonder, doesn't it? The journey of a physical paper check becoming just a packet of data is such a perfect example of how our world is changing. So what's next? What other physical objects or tedious tasks are just waiting for the right technology to come along and transform them into pure, efficient data?